All right, let's take a look at some of the examples to the right-hand side of our examples that we went through before. So to make this a little bit easier, I'll just remove parts of this so we can use some working out space. I'll leave the bit at the bottom there so you can see how we work through the problem. So let's start up here. We're going to call this just example I, and we're going to have a look at the red two lines. So if we test the examples that we looked at before, we said that if two lines bisect each other or dissect each other and they form slopes that are reciprocals, then we can actually say that they form a 90-degree angle. So let's go ahead and check if this is so. So let's label these. We're going to call this M, and we're going to call this N, and we'll call this one O, and we'll call this one P. So let's go along quickly and have a look at what those slopes would be. So the run on this one simply is 1, 2, 3, 4, 5, 6, 7. So we have a run equal to 7, and we have a rise equal to 1. So Mn, all right, the slope is equal to 1 over 7. If we have a look at the line segment OP, what we can see is it has a run of 1, and then it has a rise of 5, but remember it's -5 because we're moving down the Cartesian plane, which means line segment OP would have a slope of -5 over 1. Now, a few things that are interesting here is we see that we have a 1 in both of our slopes. We have a positive slope for Mn, and we have a negative slope for OP. However, what we notice is that they are not truly reciprocals. So, which means the angle will be very close to 90 degrees, but in this case, we would say that they are not perpendicular, these two lines. Okay, if we go on and have another look at the one at the bottom, we might have T, and we might have R, and down here we might have V, and we might have X. Running the same idea, if we start with V segment through to X, what we see is a run of 1, 2, 3, and we have a rise of 1, 2, 3, 4, 5, 6, 7, 8. So therefore, line segment Vx is equal to 8 over 3. Again, we'll change colour for line segment T to R. We might start with the rise first to make things a bit cleaner, and we can see it's 1, 2, 3. So we have a rise of 3, but you're onto it knowing that we've moved down, which is a negative movement. So it means that we have a rise of -3. Then we have a positive movement to the right of 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we have an overall slope of T is equal to -3 over 8. So if we take a little bit of space down here, what we notice is we have one line segment is -3, 8, and we have the other line segment is equal to 8 over 3. Now what we can see is we have true reciprocals here. We have a negative slope for one line segment and a positive line slope for the other. We can see that they both require 8 and 3, and they've just swapped positions in their numerator and denominator. So we would say these slopes of these lines T and R and V and X are truly reciprocals, and therefore dissect each other at 90 degrees.